This would be the sixth lecture of rotational mechanics. Okay. So in today's lecture, we'll solve some more problems from irodov. And so without any further nonsense, let's get started with the questions. Okay. So in this question, there is this cylinder. Okay. And this cylinder is in means there's two diagrams out here. Okay. Let me see. There's a first cylinder, and attached to this first cylinder is a second cylinder out here. Okay. And a rope is tied to the smaller cylinder. See, a rope is tied to the smaller cylinder and pulled in a direction. Okay. Okay. I just shown you the sign. Okay. We have to find out the acceleration. That means horizontal component of acceleration. We have to find out this horizontal component of acceleration of this block. The moment of inertia of this entire thing is given as I, where I is equals to y m into r square, where m is the mass of this body. Fair and fine. So my first question is this a case of rolling? Yes. So if this is a case of rolling, what is the direction of friction force? Let us just assume that there is no friction force and let us pull this one. So if I pull this one, okay, in which direction is the ball trying to go? The ball is trying to go in this direction or this direction. So this surface is trying to go in this direction. So friction force will act on this direction. Fair and fine. Now once I have gotten the friction force, I just have to make my equation. Okay, my first equation will be torque equation. So if I consider this the axis, okay, and this friction force, okay, friction force is clockwise, this force is anti-clockwise, okay, and let us just say, see, if this is a case of pure rolling, okay, and if the acceleration is in this direction, if the acceleration of the center is in this direction, I can say the cylinder is rolling in this direction, isn't it? Okay, because this is a case of pure rolling, okay, mass rests on a rough surface, the moment of inertia without sliding. The spool is pulled without sliding. That means there is no sliding out here. That means the case of pure rolling is occurring out here. Okay, you must understand this much. So in case of pure rolling, A is equals to alpha r, B or V is equals to omega r, and displacement of theta is equals to S is equals to theta r. Okay. So out here I got A is equals to alpha into capital R or small r. See out here. A is equals to alpha into capital R, because if I consider this point, this is the point of instantaneous axis of rotation. So the whole wheel will rotate about this point. So A into capital R. Okay, it's not small r. Just remember this. So this is the condition of our rule. Now let me apply the equation. First torque equation. Torque equation. Okay. So the first thing is torque equation is if this force is anti-clockwise or acting in anti-clockwise direction, so minus F into small r. Okay. Plus Fr into capital R. Minus force, external force into small r. Plus friction into capital R is equals to I into alpha. Is there any other force that is causing torque out here? No, I don't think so. Okay, and let me write this nicely. Okay, friction force into R minus F into small r. F at beginning doesn't look good. Friction force into small r minus F into friction force into capital R minus F into small r is equals to I alpha. Now write our force equation. Okay, I got my torque equation. What is torque? Force. Okay. I'm hopeless with the spelling of force today. Force equation. Okay. Force equation is nothing but F cos alpha minus friction force is equals to mass into acceleration. F cos alpha minus friction force is equals to mass into acceleration. Okay. Torque equation can also be written as rotational equation. Force equation also can also be written as linear equation. Okay. And now solving this two equation, I have to get the value of A. We do know that the relation between A and alpha is nothing but A is equals to alpha. So I just have to substitute something out here. Okay. Let's take this torque equation out here. Okay. And we'll find the value of friction force and then substitute the value of friction force out here and we'll get the value of acceleration. Okay. So let's take the torque equation. Fr into capital R minus F into R is equals to I alpha. Okay. Let's substitute the value of alpha. Alpha is equals to nothing but A by R. Okay. Alpha is nothing but A by R. Or let's divide the entire equation by capital R. Fr minus F into small r by capital R is equals to I A by R square. Okay. Or friction force would be nothing but F into R divided by capital R plus I into A by R square. Okay. Now if I substitute the value of this friction force out here, I'll get my equation of acceleration or I'll get my variable of acceleration. So let's get to the next page. F cos alpha minus friction force. F cos alpha minus friction force is equals to mass into acceleration. This equation is nothing but this equation out here. Okay. And friction force is nothing but F R by R plus IA by R square. So friction force is nothing but F small r by capital R plus I a by r square. Okay, F r by r plus I a by r square. Okay, so let me just solve this one. F cos alpha minus F r by capital R minus I a by r square is equals to mass into acceleration, mass into acceleration. Okay, now let me see what is the value of I. The value of I is nothing but some constant into a into capital R square. Okay, so the value of I out here is nothing but some constant into m into capital R square. So if I rewrite the equation, f cos alpha minus f r by capital R minus y m r square a by r square is equals to mass into acceleration. This and this will get cancelled. Let me take f common. F is equals to, or f into cos alpha minus r by r is equals to, let me send this entire term to the right hand side. Okay, so it will be nothing but if I take a common, it would be m plus ym. Okay, or I'll take mass into acceleration common. I'll take mass also common. Okay, so a into m 1 plus y, or m into a 1 plus y, or acceleration is equals to f cos alpha minus r by capital R divided by mass into 1 plus y. Okay, so we find out the value of acceleration. Then fine. Now once we found out the value of acceleration out here, okay, the second part of the question is asking the work performed by force wave during the first t second. Okay, if you see this diagram, what are the total forces acting out here? Mg normal, work done by mg force is 0. Okay, because displacement is in this direction, mg force. Okay, normal force is also 0. Friction force, the work done by friction force in case of pure rolling is equals to 0, because this portion or the point of contact won't be moving anywhere, it would just be going in upward direction as the wheels rolls forward. Okay, so always remember this, work done by friction force in case of pure rolling is 0. Okay, in case of impure rolling it won't be 0. Okay, now the only force that does any kind of work is nothing but F force. So can I say change in kinetic energy of the body is equals to work done by all the forces? Okay, so applying work energy theorem. If I apply work energy theorem, where work energy theorem states that change in kinetic energy of the body is equals to work done by all the forces. Okay, now one more thing. If you take your kinetic energy, considering this as the axis, you need to only take rotational kinetic energy. Okay, and you have to take moment of inertia about this point. But if you take kinetic energy, considering the center as your axis, you have to take rotational kinetic energy plus translational kinetic energy. Okay, so you decide what you want to do. Both will give you the same answer. Okay, so in this case, I'll just take my kinetic energy through the center. Okay, so half I omega square, final kinetic energy, half I omega square plus half mv square is equals to work done by force F. Now problem is I don't know the value of velocity, neither I don't know the value of omega, but I do know the value of acceleration out here. See the value of acceleration? The value of acceleration is constant out here, no? So if the value of acceleration is constant, can I apply v is equals to u plus at, s is equals to ut plus half at square, and v square is equals to u square plus 2s, isn't it? I can apply those formula, no? Since the acceleration is constant, whenever acceleration is constant, I can apply three formulas. S is equals to up plus half at square, and v square is equals to u square plus 2s. And the rotational equivalent is nothing but omega final is equals to omega initial plus alpha t. So you know the rotational equivalent. Okay, theta is equals to omega initial t plus half into alpha t square. And this one is already known. Okay, omega final square is equals to omega initial square plus 2 into alpha into theta. Okay, now I do know the value of a. The value of a out here is constant. See, the value of a is constant. Okay, now what about the initial velocity? Okay, the work performed by force wave during the first t second after the beginning of motion. So if you see this line, beginning of motion, that means what? Initial velocity and initial angular velocity is equals to 0. This line out here says that initial linear velocity and initial angular velocity is equals to 0. Okay, so if I apply v is equals to u plus at, velocity after time t is equals to initial velocity plus acceleration that has a constant value, which is nothing but this one, into time t that is given in the question. The question is asking what is the work performed after first t second. Okay, so I have to find out the velocity of the body after first t second. Okay, since I already found out the acceleration, so velocity after first t second is nothing but v is equals to initial velocity plus a into t, or v is equals to at. Okay, I also need the value of omega. Okay, what is the value of omega? Omega final is equals to, or at any point. Okay, see, at any point in case of pure rolling, v is equals to omega r, no? So if I know v is equals to omega r, omega is equals to v by r. Okay, if I know v is equals to omega r, I can easily say v by r is equals to omega. So omega final is nothing but velocity by r. What is the value of r? The value of R out here is nothing but capital R. Okay. So omega final is nothing but AT. The value of V is equals to AT divided by capital R. Okay. Now simply I'll apply work energy theory. Final kinetic energy minus initial kinetic energy. Initial kinetic energy was 0 because initial velocity and initial angular velocity was 0. So half I omega square. Let me half I omega. Omega is nothing but AT square by AT by R whole square. Half I omega square plus half m V square. V is nothing but AT whole square is equals to work done by force F. Okay. Final kinetic energy and initial kinetic energy is equals to 0. So final kinetic energy minus initial kinetic energy is equals to work done by all the forces. So let me just simplify this term. I'll take AT square common. I'll take half also common. Okay. And what I'll get remaining with? I plus m. Acha, I by R square. I'll get I by R square out here and m. Okay. From second term. Okay. Is equals to work done by force F. Acha. The value of I is nothing but ym R square. Is given in the question. Ym R square. R and R square will get cancelled. So work done by external force is nothing but half a square t square into ym plus m. Let me take m also common. Okay. Into m y plus 1. Into m y plus 1. Now let me just substitute the value of a out. A is nothing but a cos alpha minus r by r divided by m into 1 plus alpha. So out here, work done by external force is nothing but half t square m into y plus 1. Now just write the value of a square out here. Okay. A square is nothing but how much? F into cos alpha minus small r by capital R. F into cos alpha minus small r by capital R divided by how much? Divided by m into 1 plus y. M into 1 plus y. 1 plus y and whole square. Isn't it? So, okay, let me write this twice. Okay, whole square means 2 square is 2 into 2. So this square means nothing but a cos alpha minus r by capital R divided by m into 1 plus y. Okay, m and m would get cancelled. Y plus y and y plus y would get cancelled. So we'll be left with nothing but this value. Okay, so half t square divided by m into 1 plus y. M into 1 plus y. After that, this entire term will become square. So f cos alpha minus small r by capital R whole square. Okay, so this is our answer. So this was our question number which one? Question number 1.257. Simple enough. Okay, okay. See what I do out. See, we already see the diagram. Okay, out here there is a pulley, and in this pulley this pulley is free to rotate. Okay, and out here it is bound to another pulley. So if the entire system is left, what is the acceleration or find out the tension in thread? Okay, the tension in this thread is T, the tension is this thread is T. So if I just draw this diagram, can I say due to symmetry, the tension in both the wires would be same? Because there is a symmetry between this diagram. If I cut in the middle, the left hand side is equal to the right hand side. So the tension in both the wires would be same. Okay. Now let's say the mass of this cylinder is m. The mass of this cylinder is m. We have already got the idea that I have to consider two equations. First one is rotational equation or torque equation. Second one is force equation or linear equation. But in order to write those equations, I need the value of acceleration. How do I get the value of acceleration? Okay, just cover this one. Okay, just cover this one and imagine this one. Okay, imagine this one. If I just let it go, what would be the acceleration? The acceleration would be in this direction. Okay, this would be the direction of acceleration. Let's name this alpha. Okay, and if I just hold this one, if I just pull this one, this block or upper one would move in this direction. So let's name the acceleration of upper one alpha one. Okay, now let me draw the free body diagram. This is the upper block. Achha. Out here there is 2T, tension due to this force and tension due to this force. So I'm writing it at once only because both the tension would be same. Alpha 1. So can I write the torque equation about the center out here? 2T into R, where R is the radius of the cylinder, is equals to moment of inertia into alpha 1. Okay. Now if I draw this cylinder, okay, this is alpha 2. Okay. 2T, equal and opposite. If this is 2T, this is also 2T. Okay. So 2t into r, okay, torque is equals to moment of inertia into alpha. Okay. Now, since the mass of both the cylinders are same, the radius of both the cylinders are same, can I say I1 is equals to I2, or moment of inertia of this cylinder is equals to moment of inertia of this cylinder? Okay. So from these two equation, this equation and this equation, can you see that I alpha 1 is equals to I alpha 2? If I alpha 1 is equals to I alpha 2 from this equation and this equation, so I can easily say alpha 1 is equals to alpha 2, or alpha 1 is equals to alpha 2. Okay. So this much is done. Okay. Now what we do? See, if alpha 1 is equals to alpha 2, let's just name this with a common thing. Okay, this alpha, this also alpha. Let's not increase the variable from first one. Let's simplify our names. Okay, alpha. Okay. Now see, uh, let me ask you a simple thing. What is the acceleration in downward direction, or what is the linear acceleration on downward direction of this center? See, if we just hold this dot, okay, and let this thing go, this is rotating alpha r, okay. So the linear acceleration out here will be nothing but alpha into r. So the linear acceleration out here is nothing but a is equals to alpha into r. Okay, alpha into r, where r is the cylinder, or where is the r is the radius of the cylinder. I'm just holding this one and just letting this one go. So this one would rotate. So if this rotates with angular velocity alpha, the acceleration at the center is nothing but alpha into r. Okay, so this is the instantaneous axis of rotation. Okay. But the problem out here is this row is also coming down now as this upper cylinder rotates. Okay. So my problem is, what is the acceleration of the rope at this point? The acceleration at the rope of this point is also nothing but alpha into r. So the total acceleration at the center of this cylinder is nothing but acceleration due to the rotation alpha r plus acceleration because the thread is coming down. Okay. Plus acceleration because the thread is coming down. Understood this one? So the total acceleration of this block, or the center of this block, or center of this cylinder, would be nothing but alpha r due to the rotation of the cylinder plus alpha r because the string is coming down with alpha r, which is nothing but 2 alpha r. 2 alpha r. Now if I just write down the equation out here, okay, what is the acceleration? Acceleration is nothing but 2 alpha r. Okay, so let me write down the equation mg minus 2t. Let me write down the linear equation or force equation. Force equation is mg minus 2t is equals to m into a. A is nothing but 2 alpha r. Okay. Okay. And first equation I get 2tr is equals to I alpha. Okay. Or 2t is equals to I alpha by r. Let me send the r to the right hand side. If I just add this entire thing, I'll get 2t and 2t to get cancelled. mg is equals to 2m alpha r plus I alpha by r. Now what do I have to find? I have to find out the tension in this tree. Okay. So let me find out the value of I alpha by r. Achha. Let me just isolate the value of alpha. Okay. Okay. I is nothing but m r square by 2. Okay. I is nothing but m r square by 2. Moment of inertia of a cylinder about the center is nothing but m r square by 2. So let me just write this equation. Okay. How do I write this equation? Mg is equals to how much? 2m alpha r. 2m alpha r plus how much? Plus m r square by 2 into alpha by r. Plus m r square by 2 into alpha by r. Isn't it? Into alpha by r. I have to solve for alpha. And after I solve for alpha, to find out the value of tension force, I'll just substitute the value of alpha out here. Okay? Okay. So let me take alpha common. Mg is equals to 2mr plus mr square by 2 is equals to alpha by r. So m and m will get cancelled. Okay. So you're left with 2r plus r square. G by 2r plus r square by 2. Okay. Into r. This r will come to the left is equals to alpha. Now if I put the value of alpha, if I put the value of this alpha out here in this equation, I'll get the value of tension. 2t is equals to I alpha by r. So 2t is equals to I alpha by r. I is nothing but mr square by 2, isn't it? Moment of inertia of a cylinder. Mr square by 2 into this r. Okay, into this r. The value of alpha is nothing but gr divided by 2r plus r square by 2. Okay, 2r plus r square by 2. I think there's some weird thing. Acha. A in alpha. Acha, see out here, I made a mistake out here. If I take common out here, okay, out here we have to give one square out here, 2r square. Okay, see, there's no r in the denominator out here, no? Okay, so if I take a by alpha by r common, I have to take square out here. Yes, 2 square and 2r square. Okay, acha, now it's better. So 2t is equals to how much? M r square by 2r into gr divided by 2r square plus r square by 2 is nothing but 2 plus 1 by 2 is nothing but 5 by 2. 5 by 2 r square. So r square and r square would get cancelled. R and r would get cancelled. Achha, out here 2 and this 2 would get cancelled. So if I remove all the cancel out terms, what am I left with? I'm left with 2t is equals to mg by 5 or 2t is equals to mg by 5 or t is equals to mg by 10. Okay, so this is our value of tension force that I got out. This was a simple question. Okay, the only thing that you have to note out here is the acceleration of the bottom block is nothing but total acceleration due to rotation plus acceleration due to slipping of the spring or coming down of the spring. Okay, now let me move on to this third question. Okay, out here you can already see the radius of this larger cylinder is 2r, the radius of the smaller cylinder is r, and the mass out here, this is the diameter. Okay, out here, this is wrapped to the smaller cylinder, or upper thread is wrapped to the smaller cylinder, and from this smaller cylinder, this is attached to a larger cylinder, and a mass hangs out. Okay, mass hangs out. So as soon as this is released, you have to find out the acceleration or rotational acceleration of this. You have to find out the linear acceleration of this block. Then fine. The first thing is how do I write my equation? See, out here this tension is T1, this tension is T2. Okay. So if I consider my body out here of mass capital A, okay, this mass is capital A. Out here T1, out here T2, okay, and mg. Okay. Can I write my torque equation considering this point as the axis of rotation? Why I'm saying this? I'm considering this point as the axis of rotation. Why did I do that? See, there's two things. First thing, it will be much easier to find out the acceleration of this. Why? Because whatever this thing rotates, see, if this thing rotates by alpha, okay, suppose I'm saying the acceleration of this block is alpha in this direction. So if this block rotates by alpha, that means this point, okay, this point at the edge of the disk comes down by alpha into this much r, isn't it? This much distance, okay, and the acceleration is nothing but alpha into this much r, okay. So if this is r, okay, and this much is nothing but 2r plus r, which is equals to 3r. So let me write down my torque equation. Torque equation or rotational equation. Torque equation is nothing but mg into r. R is nothing but radius of the smaller cylinder. So mg into r plus T2 into how much? T2 into this point to this point is nothing but 2r plus r, 3r is equals to I into alpha. And alpha is the rotational acceleration. Okay. And force equation. Force equation or linear equation. Force equation of this body is nothing but T1 minus T2. This is T1, T2. Achha, do I need the force equation? I don't think I need the force equation of this body. Okay. Since I already wrote my equation from instantaneous axis of rotation. See, if I see this one, this would be the instantaneous axis of rotation. No? So since I have already written my torque equation from instantaneous axis of rotation, I do not require a separate or the any separate kind of thing or force equation of this body would be worthless. Okay. Only thing I need to remember out here, the I, moment of inertia, is taken about this axis. Okay. So moment of inertia of the center axis is nothing but given as I. So if I shift my axis out here, I can apply parallel axis theorem. So this I out here will be nothing but moment of inertia over the center plus mass into r square. Okay. So this will be nothing but I plus mass into r square. I plus mass into r square into alpha. Now force equation of the smaller block, this block. I can apply force equation out here. No, I do not need to apply force equation out here because I have taken my equation, torque equation to the axis of rotation. Fair and fine. I won't be taking force equation out here. But I do need to take the force equation out here. Okay. So if I take the force equation out here, this is mg, this is nothing but T2. Okay. So mg minus T2 is equals to A. And what is the value of A? The value of A out here is nothing but C. If this point comes down with acceleration, this point comes down with acceleration alpha into 3r. This will also have the value of acceleration alpha into 3r. Understood this much? Okay. So my force equation becomes mg minus t2 is equals to m alpha into 3r or 3m alpha r. Let me write this neatly. 3m alpha r. Now solving this two equation, I'll get the value of whatever is asked. Find the acceleration of the weight. So solving this two equation, I'll find the value of alpha. If I find the value of alpha, I'll get the value of a. So this is my equation one. This is my equation two. Let's solve this quickly. Okay. I won't waste much time in solving the equation. Let me take this one. Achha. mgr plus 3 mgr plus 3 into d2r. Okay. mgr plus 3 into d2r. d2r. Okay. Is equals to I plus m r square into alpha, or I alpha plus m alpha r square is equals to I alpha plus m r square alpha. Fair and fine. This is my torque equation. Okay. And this is nothing but mg minus t2 is equals to 3m alpha r. So mg minus t2 is equals to 3m alpha r. Okay, 3m alpha r. Now the first equation, I'll divide the entire thing by r. So mg plus 3t2 is equals to I alpha by r plus m r alpha plus m r alpha. I divided the entire thing on the first equation, left hand side and right hand side by small. Okay, now I'll take this equation. If I multiply this equation by 3, left hand side by 3, right hand side by 3, what do I get? 3 small mg minus 3t2 is equals to 9m alpha r. Okay. Now this and this would get cancelled. Now g into m plus 3. Okay. On the left hand side, on the right hand side, what can I take common? I can take alpha common. Okay, is equals to alpha I by r plus m r plus 9m r. Okay, and let me take r also common. Okay, let me take okay. Let me take r also common. Okay. So g into m plus 3m is equals to alpha into, I'm taking alpha by r common. Okay, so I plus m r square plus 9m r square. Okay, so alpha is equals to nothing but gr. This r can go to the left hand side. Gr into m plus 3m divided by I plus m r square plus 9m r square. And I have to find out the value of acceleration. The value of acceleration is nothing but 3 into alpha r, or alpha into gr. Acceleration is equals to 3 alpha r, or acceleration is equals to 3 into r into alpha. The value of alpha is nothing but gr m plus 3m, okay, divided by I plus m r square plus 9m r square. 9m r square. So this is our answer. 9m r square. Okay. So this is the value of our acceleration. Okay. This was our question. This was our question. Now this question. Okay. If I pull this thread with a, what is the acceleration of this part? Okay. The angular acceleration of this disc will be in this direction. Okay. The question is simply saying out here there is a frictionless surface. In this frictionless surface there is this thing kept out here, and at the center out here there is a wheel kept out. Okay. And this cylinder or this wheel is of mass m1, and this thing, this shape is of mass m2. And if I pull a thread out here, see, if I pull a thread out here and this frictionless, this will also accelerate in this direction. Okay. And this wheel will also rotate in anti-clockwise direction. Okay. We have to find out the acceleration of this wheel. Okay. So if I consider my axis of rotation out here, okay, what is a torque? Torque is nothing but F. So torque equation, if I write down the torque equation or rotational equation, it is nothing but F into R is equals to I alpha. Okay. Now force equation. Force equation. Force equation is nothing but force. Is there an opposing force? No. Force is equals to mass of this body plus mass of this body into acceleration. So m1 plus m2 into acceleration. It is wise to note that the acceleration of this body was right would be equals to acceleration of this body was right. See the constant motion. These two bodies attached, no? So by constant motion or by simple observation, I can easily say with the wheel, with the center of the wheel moves forward, this moves also forward with the same acceleration. Okay, fair and fine. Now I have to solve this two. Achha. Out here, this block is nothing but m2, and this is nothing but m1. So out here I can write alpha as, sorry, not alpha, I as m r square by 2, or m1 r square by 2 into alpha. Okay, or F is equals to this r and this one will get cancelled. M1 r alpha by 2. If I substitute the value of F out here, what do I get? M1 r alpha by 2 is equals to m1a plus m2a. Okay. Is there any relation between A and alpha? I don't think so. A is linear acceleration, alpha and alpha is nothing but angular acceleration. Okay. So what do we do now? Okay. I do know there is a given term f out here. M1, M2, and R is also given. Okay. So I can say that this relation was not equal. This entire thing was not equal. See, alpha and this A are independent. They have no relation with each other. Okay. So I can easily say that 2f by m1 into r is equals to alpha. Okay. And linear acceleration is nothing but f by m1 plus m2. Okay. Now the question is asking us the acceleration of point k. That means in this thread there is a point k out here. Okay. And what is the acceleration of this point k? See, if I see properly, if I just hold this entire thing, okay, I'm holding this entire thing out here and pulling this one. So acceleration of this entire thing will be nothing but alpha into r. Okay. But if I leave this one, the acceleration of this point will be nothing but alpha into r plus acceleration of this entire block, isn't it? Acceleration of this point would be acceleration due to rotation, which is nothing but alpha into r plus acceleration due to motion, a linear motion, plus a. Understood this point? So acceleration of point k is nothing but a plus alpha into r, where r is the radius of the cylinder. Or acceleration of point k is nothing but what is the value of a? Force divided by m1 plus m2. What is the value of alpha? 2 into force divided by m1 r into r. So r and r will get cancelled. Okay. So I'll be left with acceleration of k is nothing but, let me take f form, 1 by m1 plus m2 plus 2 by m1. Let me leave acceleration as this is. Now the second part of the question. The kinetic energy of the system t seconds after the beginning of motion. After kinetic energy of the system. So the kinetic energy of the system would be nothing but rotational kinetic energy plus translational kinetic energy, isn't it? So if the value of acceleration, see acceleration of point k is constant, but the value of linear acceleration is also constant. See out here, f divided by m1 plus m2, and the value of rotational alpha is also constant. Okay. So what is the total kinetic energy? Total kinetic energy is equals to, if I'm taking, there is no point, I have to take my kinetic energy through this axis passing out the center, because there is no concept of rolling out here, no? There is no relation between A and alpha. Okay. So half mv square plus half I omega square. Okay. Initial kinetic energy is nothing but zero. See, beginning of motion. Now, if the angular acceleration and linear acceleration both are constant, I can simply apply v is equals to u plus at. Okay. This is equals to ut plus half at square, and v square is equals to u square plus 2s. The rotational equivalent of this formula will be omega final is equals to omega initial plus alpha into t. Omega initial is 0, u is equals to 0. Why? Because the question is given at the beginning of motion. Okay. So final velocity is nothing but a into t. What is the value of a? F divided by m1 plus m2. So f divided by m1 plus m2 into t. And what is the value of angular acceleration? Alpha into t. The value of alpha is nothing but how much? 2f divided by m1 r. 2f divided by m1 into r. Okay. Into t. So my net acceleration, sorry, my total kinetic energy is equals to half m into v square, f divided by m1 plus m2 into t whole square plus half I omega square. I is nothing but rotational kinetic energy of this thing. Okay, m square by 2. I into 2f divided by m1 r into t. What is the value of I? The value of I is nothing but into t whole square. Into t whole square. The value of I is nothing but m square by 2. M r square by or m1 r square by 2. This is nothing but kinetic energy at time t. At time t. Just simplify the following. Okay. Half m, it remain s square t square by m1 plus m2. Half mv square. This m out here is nothing but the total mass. Half mv square. The entire system is moving with velocity, you know. So half m1 plus m2. This would be nothing but m1 plus m2. Okay. Plus half. The only thing that is rotating is nothing but the wheel. So moment of inertia of the wheel is nothing but m1 r square by 2 into how much? 2 square is nothing but 4 f square t square divided by m1 square r square. Okay. And so this is our answer. And let me just simplify. Okay. This and this square will get cancelled. 2, 2, 4 getting cancelled. m1 square, m1 getting cancelled. R square getting cancelled. Let me just make it neat and clean. This got cancelled, this got cancelled. This. m1 square, r2 square, r2 square. Okay. The remaining thing is nothing but half a square t square divided by m1 plus m2 plus a square t square divided by m. The half also got cancelled out. Let me just introduce the half out. 2 by 2. Okay. Or if I take half a square t square common, I can get 1 by m1 plus m2 plus 1 by or 2 by m. This is the kinetic energy at time t. At time. Okay. So this is a simple straightforward answer. Now see this question. Okay. So in this question, there is a blank out here. There is a blank of mass m1. Okay. And there is a sphere out here, a solid sphere of mass m2. A constant force is applied on this mass m1. Okay. The question is asking what is the acceleration of this m1 such that no sliding takes place across this surface or no sliding takes place out here. Okay. So m2 and m1 out here in this surface, there is rolling occurring out here. Okay. And rolling has to be such that there is a pure rolling out here. That means no sliding is out. Okay. So if f1 is goes towards right, let's say m1 moves right with acceleration a1. Okay. So in which direction is the friction force? See, assume the surface to be frictionless. If m1 tries to move towards right, this surface tries to move or tries to slip towards right. No. So friction force, okay, on m1 would be towards right. Equal and opposite reaction on sphere would be towards right. Okay. Now see, this friction force is trying to rotate this m2 in anti-counterclockwise direction. So there would be an alpha out here. Isn't it? And if I see the linear acceleration, let me see the center of the sphere is moving with some acceleration. Let that acceleration be a2. Okay. So I have my body 1 blank and body 2 sphere. In body 2 sphere, there will be two equations. One is rotational equation and another one is linear equation. Okay. And a2. And in a slab, we have force and friction force and a1. Okay. Mass m1 a1. Fair and fine. Okay. Now I need a relation between a1, alpha and a2. Why? Because the number of equations. See, how many equations would I get from out here? I'll get two equations, rotational equation and linear equation, or rotational equation, that means torque equation and force equation. Okay. Out here I'll get one force equation. So I'll get three equations, but out here variables are a1, a2 and alpha. So I need one more equation that justifies the relation between a1, alpha and a2. See, if you see this point out here, see this white point out here. Okay. What did I say anything about rolling motion? Rolling motion is nothing but a combination of rotational motion plus linear motion. So what is the velocity of this point? The velocity of this point is nothing but velocity due to rotational component plus velocity due to linear component. Similarly, what is the acceleration of this point? The acceleration of this point is nothing but acceleration due to rotational component, which is nothing but alpha into r plus a2. And the acceleration of this point is equals to a1. Why? Because this surface or the sphere and the slab doesn't slip over each other, isn't it? There's no case of slipping. So the acceleration of this point for sphere would be equals to acceleration of this point for slab. So I can easily say a1 is equals to alpha r plus a2. Now let me write this a2 plus alpha. a2 plus alpha. Now let me write down the remaining equation. Out here force equation is nothing but force minus friction force is equals to m1 a1. This is my equation number 1. Out here let me write down the torque equation about the axis from the center. Torque into radius is equals to I alpha. I alpha. The value of I is nothing but torque into radius. The value of I for solid sphere is nothing but 2 by 5 m2. This is mass 2. m2 r square and alpha. R and R would get cancelled. Rho is equals to 2 by 5 into R alpha. So let me write this thing out here only. Okay. Friction force is equals to 2 by 5 m2 r alpha. This is nothing but the torque equation. Torque equation. Just rewind back 5 seconds and see how I wrote the equation here. Torque is equals to I into alpha, but I is equals to 2 by 5 m2 r square. Okay. And if I write the force equation out here, this is my equation number 3. Force equation. My force equation would be nothing but friction force is equals to m2 a2. Friction force is equals to m2 a2. This is my equation number 3. So solving this 4 equation 1, 2, 3 and 4, I'll get the value of how much? a2 and a1. So let's solve this equation. Okay. My first is friction force, force minus E is equals to m1 a1. m1 a1. This is my equation number 1. My second equation is nothing but friction force is equals to 2 by 5 m2 r alpha. Friction force is equals to 2 by 5 m2 r alpha. This is my question number 2. My equation number 3 is friction force is equals to m2 a2. Friction force is equals to m2 a2. And my fourth equation is a1 is equals to a2 plus alpha. a1 is equals to a2 plus alpha r. Now if I just combine this equation 1 and 3, okay, combining 1 and 3, 1 comma 3, I'm just adding this first equation and third equation, okay, friction and friction will get cancelled. So F is equals to m1 a1 plus m2 a2. Now what do I need? The question is asking find out the acceleration of the plank. That means I need to find out the value of a1. That means from this equation somehow this value of a2 must disappear. Okay, how do I make the value of a2 disappear? Okay, let's find out the relation between a2 and a1 from this equation. From 2 and 3, from equation 2 and 3, can I say m2 a2 is equals to 2 by 5 m2 r alpha? Because both are friction force, no? m2 a2 is equals to 2 by 5 m2 r alpha, or m2 and m2 get cut. R alpha is equals to 5 by 2 a2 is equals to r alpha. Okay, now if I substitute this value of r alpha, okay, what do I get? a1 is equals to a2 plus 5 by 2 a2, or a2 plus 5 by 2 a2 is nothing but 7 by 2 a2. a1 is equals to 7 by 2 a2. Now I got this equation and this equation. I can simply find out the value of whichever is required. Okay. Okay. Now let me find out the value of a1. So a2 is equals to how much? a2 is equals to 2 by 7 a1. Now if I just substitute the value of a2 out here, what do I get? F is equals to m1 a1 plus m2 into a2. a2 is nothing but 2 by 7 a1, or F divided by m1 plus 2 by 7 m2 is equals to a1. So I found out the acceleration of a1. And what acceleration in the plank? I found out the acceleration of plank and find out the acceleration of sphere. So acceleration of sphere is nothing but a2. a2 is nothing but 2 by 7 a1. 2 by 7 a1, or a2 is equals to 2f by 7 into m1 plus 2 by 7 m2. Simple enough. Okay, so this is our question. Okay, so this was our answer.